Okay. Ready? Okay, so welcome everyone to a new colloquium in the Northwest Database Society series. Today is my great pleasure to introduce Laurel Orr. Laurel is a researcher and an ML architect at Numbers Station. Before that, Laurel was a postdoc at Stanford with Chris Ray. And before that, she got her PhD here from the University of Washington. And before she left, one important thing she did, she actually architected the layout of the student. So if you like this layout, you should thank Laurel.
Yeah, I mean, myself and other students, yes. Dan was like, "Oh, you've never been to the new office before." Oh, thank you. I don't know why I'm doing myself. And I remember when it was set up, like I remember building that table. It was all very exciting because I was leaving as we finally got a better office because we used to be on the 5th floor, I believe, and like this really with like the worst whiteboard you can imagine, right? And there was like that, the like whiteboard walls was the thing, and it was anyway, so yeah, no, thank you guys so much for having me. I actually moved back to Seattle about 8 months ago because I loved it so much when I was a PhD student. It was yeah, so it's great to be back and to actually see everybody. And so today I'm gonna talk a lot about, so at Number Station we do a lot of like basically data analytics and data, the data stack. And so just to give a very high level overview of the pipeline that we're kind of working with here, and also as a caveat, I think every image I generate here is mainly me going to OpenAI and asking for an icon, and then I take the first one and say it's good enough. So which is also like a very fun way to build sites. So anyway, so at a very high level, the kind of data pipelines that that we work with and that I work with are really thinking about end to end, where the end goal is kind of this data analytics piece, right? So you usually start with raw data, you extract the information, you do some data cleaning, and then it ends with the kind of this data analytics component, which includes, text-to-SQL, where you're answering queries over the data, looking at charts, looking at analytics, analysis to kind of understand what's going on with your data. So we also, and then we're saying to do a lot of generative AI. And the thing that we've really seen in the last couple of years is you've seen a lot of amazing work applying sort of these large language models to the kind of these different components of the pipeline, right? You've seen work in using LLMs to do information extraction from the web and Wikipedia. You've done some work on data cleaning and on information entity linking, and also a lot of work on text-to-SQL and visualization recommendation, and all sorts of stuff have been applying language models to these kind of different components of the pipeline. Now, this has been, it's been really exciting work and great kind of places to latch on. But the thing is, what you're seeing, and oftentimes you're seeing this in industry too, is a lot of companies that, historically just solved one of these problems are kind of now having this like now with AI sticker on the product that's sort of enhancing it and making it easier for the user to engage with. But the problem that actually, Leilani, you were mentioning earlier is that this isn't really making the analyst's life easier. It might be making it a little faster, but the real thing is that in enterprises, each of these steps is usually handled by one or many separate teams. And so to build an entire pipeline, you have this really cumbersome back and forth communication that happens where the data cleaning team has to go and update or tell the modeling team to fix something, or the reverse can happen. I mean, we've had customers who come and say, oh, like our data team changed our entire schemas up underneath us and we need 5 days to rebuild like all of our indexes and everything, right? And so this is very kind of manual process that has a ton of mental burden on the user to kind of understand each component and kind of transfer and move data along the stack to get to the analytics that they want to. And so this kind of AI-ifying of components is again, it's speeding things up, but it's not really making it easier. And the other thing is that it really is ignoring what happens after the analytics, right? Like the goal of analysts is not just to generate, sort of Tableau dashboards, right? I mean, that's great, but they're not like, oh, here's a picture, like I'm going home, right? They have a real problem that they need to solve. And the analytics is merely the way that they're understanding what the right solution is. At the end of the day, they have to go and actually resolve said problem. And this can be a lot of different things, right? This can be submitting tickets or sending emails or creating a work order request, or maybe like actually doing marketing if they care about that, right? So tons of different actions they need to take, but ultimately like their end-to-end workflow includes this kind of action-taking resolution. And so at the end of the day, you're getting this thing that these kind of language models are being applied to, again, different components, but they're not really solving this end-to-end workflow that the analysts are dealing with. And as a teaser for this talk, what we're getting into, and this is actually something I've been thinking mainly a lot about the last couple weeks and a little bit before that, is this idea of analytical agents, right? And I'm going to talk a lot about kind of the hype and how we got here, But really the promise here is that instead of having humans do everything, you want to start moving into having more of this kind of automation and these models and AI take over these components. Now, the real thing that is really exciting about this is that instead of having this kind of cumbersome human communication process, the dream is that you could almost be automating the process and the kind of translation of data from each part of the pipeline, right? And so you have this ability, the potential, this dream of actually being able to automate a lot of the workflow for a user, and really get this like end-to-end automation, which is what companies are really after, right? I mean, we've been out there, I mean, our companies are focusing a lot on the analytics piece, but we're finding out that a lot of customers, like, they don't want it unless they can really solve their problem completely, right? They're happy with it making it faster, but they really need this kind of end-to-end workflow automation. So before I talk about how we get there, I'm also gonna kind of go over a brief overview of these like LLM agents. And I'm sure you guys have seen them kind of pop up on Twitter. And I kind of just want to go over at least to make sure we're kind of on the same page for what they are. And again, the kind of trajectory of how we got there with agents. Because oftentimes I find with LLMs, you see these demos on Twitter and are like, oh my gosh, this is so amazing. How did we get here? Like, it's magic. And it's like, well, it's actually like multiple years of effort. And you know, that's actually much more gradual progression if you think about it. So at the core, an agent, and this is sort of a classical notion of what an agent is there these basically independent entities that can take an action. And so this has been, I think, one of the earliest references I found to kind of agents was like 1980s. They had these AI agents even back then. And the whole idea is that at the end of the day, agents take in some notion of what they can do, some goals, some like prior knowledge, as well as information from their environment, such as like experience and observations. And at the core, all that their output is an action on the world. Right, and you can think of this as even in the classical kind of reinforcement learning setup where you have agents that are like literally taking like actions in a game or something, and same with RL and robotics as well. Like this is a very classic definition of an agent. Now, what's changed recently, and this is, I think I saw early agents almost like 2.5 years-ish ago, maybe a little bit sooner, is that people started to realize that, hey, look, with these language models and some prompting tricks and a little engineering, you could kind of get at an agent here. And so here, for example, you have, maybe there's one of your agents asking for some tuna from Petco, as all cats want. And so here, for example, and this is a very kind of sort of fairly well-known prompting technique, one of the early versions of that, what I saw, this kind of agentic behavior, where you actually would prompt a model to go and take an action for you. And so here, this is a React style. And the thing that matters is there's some notion of like a thought, like a planning stage almost, an action that they can take. And then after the action was done, you'd kind of go back and give the observation to the model, and they'd kind of be able to take steps for you. So you'd have like thought one and then thought two and so on and so forth. And so if you feed this to the model can say, oh, hey, look, I want you to go and search on Petco. And this was all done in text, right? It was still a language model. But with engineering and some, parsing of the output, you could actually understand that search was going to be the action of actually going on Google with, Python, Chromium bindings or something, and going and actually searching on the web for the keyword that the model gave. And here I am glossing over some details, which is actually a pretty interesting piece as well, which is how do you give the observation back to the model? Again, right now it has to all be in text form, because when this we're still mainly all in text space. You're seeing some multimodal stuff come out, but by and large, you're still in text space. And so there's actually kind of an interesting problem of how do you sort of serialize an output that isn't naturally in text. I'm not really going to talk about this in this talk, but kind of an interesting thing to think about. And so here we really saw this like first notion of a model being able to act for you. And an interesting thing is if you noticed, about again, maybe 1.5 years ago, maybe sooner, you started to see companies that support these models have really good integration for tools. Early versions were called function calls, and they moved into tool calls now. And you're really seeing these companies are understanding that this ability to take action is going to be really important. And so going back to that same example of the cat asking for some tuna, here what you do instead, and this is code copied from kind of an example from OpenAI, but in essence, they're giving you the ability to encode actions now as strict functions that both have notions of properties like keyword arguments as well as types to them. And you're giving developers a much easier way to engage with these external function calls and tools. And for anyone who's ever had to deal with a looser form of model outputs, like it's kind of painful to parse the output and make syntax errors, right? It's kind of cumbersome. And so here you just have a much more structured, clean way of engaging with tools with these kind of large language models. And a lot of open source models as well are supporting tool calls. And so the thing to take away from this is that basically it's making it really easy for users to act and call out to different tools and different functions. And it's a signal that this is really where people are excited about, where the world is kind of heading. So up until this point, we still really only had some notion of one agent doing a single action for the most part, right? You'd see demos of agents searching. I think there were some silly ones of like people ordering pizza or like choosing a movie for you. You know, and it was cool. Like it was really exciting for you to like type in a text prompt, it would go and order something for you, right? Like that was still really exciting. But at the end of the day, that's not really a useful, I mean, like it's helpful, but it's not really capturing this notion of end-to-end workflow of really completing a task for a user. And so if you really think about it, the cat doesn't just want to look at some tuna, it really wants some tuna. And so if you expand it to be a more complicated task, where it's actually wanting to order some tuna from Petco, but like deliver it on ice, because I don't know, I had to make it more complex somehow and thought of what a spoiled cat would want. And so here, when you actually think about having a model do this, you're now dealing with a fairly more complex space of tools. You have to have some notion of being able to look at emails and submit emails, submit orders, maybe look at credit card information, search the web. So, you know, you have now a much more complex set of tools and you're having one agent kind of having to do everything. And what a lot of work found is that at this point is when you started to have a lot of quality degradation, right? This notion of a single agent workflow was struggling to kind of complete these more complex tasks, right? It could take one step, but it kind of struggled with the multiple step workflow there. And so recently, and this is really, I feel like it kind of exploded in the last 6 months, you're seeing a lot of work on this multi-agent work, right? And really all this is doing is instead of having one model and maybe a user, you now have a user and multiple models. And the real thing here is that you're going to be able to have specialization between the different models. And so the classic way that you see this is you always have some notion of a planner agent, an agent that's going to go and take the task and break it down into sub pieces. And this planner agent is going to be like, okay, like first I have to search for the tuna, and then I have to order it, and then maybe find the email, and then email the people and, you know, ask for ice. And under the hood, this planner agent is going to, you know, go through each step, and you're going to be able to say like, hey, look, like who do I need to ask and what do I send them? And so you're going to get this planner agent that's now calling out to these sort of sub agents that, you know, one of them is going to be the search agent, one of them will maybe be the Petco agent, an email agent, so on and so forth. And the thing here is that you're getting a benefit for really for two reasons here. For one, again, as I mentioned, you're able to have agents specialize. And the thing there is that with specialization, it just generally is much easier for the models. It's much higher quality because they're able to do really well at one thing versus semi kind of okay at a lot of different things. And you really need the specialization to kind of get high quality. And the other huge thing here is this notion of planning. And the planning, not only is it useful for coordination, but it's also breaking a complicated task into simpler subtasks. Like if I asked you to code, right, and I'll come to a coding example in a minute, you don't just sit there and like do the whole thing, right? You usually stepwise break it down into these much easier to solve components, and then you kind of build it back up from there. And so it's leaning into this idea of kind of how humans naturally complete tasks, which is just generally why it's pretty interesting. And there's a whole line of work which is studying multi-agent collaboration purely from like a psychology, sociology perspective of like, ooh, like what if you put them in a prisoner's dilemma? Like, do they like sabotage each other or not? It's I mean, not necessarily useful, but really interesting to kind of see how models behave. Because again, this is very much how humans do things. And now one thing, and this is sort of my somewhat biased take from trying to build some of these agent workflows, and something that I don't see talked about a lot, but from the engineering side, and my take is it's a lot easier to build these things. Because if you think the abstraction, and this was taken from a fairly popular agent package from Microsoft called AutoGen, which is a terrible name. Oh, it's not, I mean, it could be worse. It could be better. But like AutoGen, everything is like AutoGen with LLMs. So you like Google AutoGen and there's a ton of stuff that pops up. But anyway, so it's a very popular package of these kind of agentic workflows. And their core paradigm, if you dig in, they have this agent class. And all that it really matters, they do three things. They can send a message, they can receive a message, and they can generate a reply. And you could almost argue you could probably wrap the last two into one, but there's like some notion of like sometimes you just want to like receive a message and not do anything. So they kind of break apart that logic a little bit. And now if you build an entire pipeline with this, right, like it's this incredibly decentralized modular way of building an interface. And for me, and like, you know, when trying to build these things, there is no, like right now we have in essence monolithic control flows. So you have a user come in and you have this very kind of complicated, messy piece of code that controls every step of this like language model pipeline. And if you move away from that, all that goes away, and you're in this very decentralized, kind of beautiful way of building a pipeline. And so for me, like I'm very excited about it. To be clear, like if it doesn't work, then you're in deep trouble, because then they're really hard to debug. And you know, so I realize this is a bit of a pipe dream, but there's something really intriguing about this way of building systems. And you're even seeing people build like RAG agents that like do retrieval for you, right? So there's I don't know, I could see a future where you're getting like entire backend systems built with these like agent microservices kind of pipeline. It's interesting. But a side note there, because I've been pretty excited about this. And so one thing that you're seeing with this sort of multi-agent paradigm is completing these very complicated tasks. And I hope most of you have seen this, like Devin, it was like popular on Twitter recently. It's from Cognition AI, I believe, is they were some of the first people to really show how these agents could do, and this was coding tasks, right? So they had this complicated coding tasks, and they had these really kind of fun videos of a user being like, hey, look, code me something that calls out and, I don't know, train some models and measures performance. And so you have this like chat window of their Devin bot kind of showing what's going on. And they have these 3 agents that are all kind of coordinating and working. One of them is coding, one of them is running it on the bash, and then one of them is like handling Google to kind of search for documentation and stuff. And so they have these really fun videos showing these agents work. And they actually did some evaluations, and they were about 3 times better than any existing model on completing some code evaluation benchmarks. Now, the performance was still overall, like everyone was doing poorly, like other models were 5% and they got up to like 15%, which is still bad, but was still a huge lift from where we were before. And they also did some really interesting stuff on the UI, which you can't see here, which was looking at this notion of provenance, of seeing what all the models did over time, because I guarantee you, like in the remaining 85% of the cases, the models probably did a ton of the work to get there and just like couldn't figure out some pieces. So there's like some really fascinating things going on in this space. And this was really what kind of blew a lot of people's minds were completely blown when they saw this. And so for my, so as I mentioned before, so now I want to kind of pause it and talk a little bit about what it actually takes to make these multi-agent workflows work. And then I'll kind of go into each of these sub-steps as we go on. And again, this is very much my working hypothesis. This is a fairly new area of research. So on one side, as I mentioned earlier, you really need individual agents to be very high quality. And in particular, when I'm going to bring the story back to data analytics, there's a couple tricks and things that you need to really make models work over enterprise data. Once you have good single quality agents, the next piece is really how do you get good planning and coordination between the agents, right? Because if you have a good plan and you have individual agents that are good enough, right? Like, like the dream for advisors, you want like all your students to like have like great plans and coordination and be amazing to pull them off. And so you can just sort of sit there and tell them what to do and magic happens. I know that's not how it works, but that can be the dream. So if you have these 2 pieces together, right, these kind of multi-agent workflows might actually work. Okay, so I'm now going to kind of dive into this first piece, which is really how do you make good single agents for data analytics. Learning, almost put it here. And so for this, I'm going to focus a lot on, let's just pretend we're building a text-to-SQL agent. It's something I've spent a lot of time on, and it's kind of a classic database problem for decades. That's kind of how do you talk and communicate with your data. And so I'm going to kind of walk through some of the problems that you have building a text-to-SQL agent, and then kind of up-level that into the fact that actually these problems are going to be for any data agent for the most part that you're dealing with. And so just to make sure we're kind of on the same page with text-to-SQL, it usually begins with somebody asking a question. There's some schema of the data. How it typically works with language models is you kind of just shove all this at the model and you say, give me SQL, and it surprisingly gives you almost always SQL. And then you can go and like have this execution layer that goes and executes the SQL and returns it to the user. Right, so it's very much trying to, you can almost picture it as like democratizing the ability to query your data, because you have people who don't know SQL able to actually ask questions over their SQL. Now, although this was, and this is one of, I think, the earliest demos I remember I saw over GPT over structured data was actually text-to-SQL. And they're like an old school example playground. They had this like text-to-SQL example. And so this is, and you've seen a ton of demos pop up that are doing this. But if you really dig in and look at it for enterprises, for the most part, it really doesn't solve all the problem. It's about an 80% solution. And what you see here is that there's a lot of issues where the model does not understand, although go through in a minute, is that the models are going to be just struggling over a lot of the enterprise data, right? On the right-hand side, you're seeing some posts around them talking about it just fails in unexpected ways. You can't trust the results all the time, and you still really need a business analyst to be able to perform this task. And so there's something here where there's a gap, right? Like we have this text-to-SQL, we know it kind of works, but on enterprise data, it seems to fail and at least not be reliable enough to be deployed. And so the real question is understanding, like, what are some of the core tricky aspects of kind of building a text-to-SQL agent over enterprise data? Now, one of the first things you run into pretty quickly once you deal with real data is that users who are asking questions don't really know the schema of their data. And the schema of the data is not at all designed for people asking questions. And so if you look, they'll have columns that are nothing but like weird acronyms or like random numbers, like things as for me, even as looking at the data, I have no idea what it means. And users are going to come in, for example, and this was actually, I think, almost taken from a real customer. They were saying, hey, look, show me, high priority work orders from July of 2023. And like, let's pretend we have a data set of, work orders for over different states, right? And some information about the urgency and priority and dates. So so the model, if you just to ask it high priority, it actually does a pretty good job guessing, but there's no way it knows the right answer, right? So high priority could be urgent work orders, it could be priority of urgent, it could be some mix of the two. And even looking at from July, given the data, like it could be looking at completed on date or created on date, or maybe some average of the two dates, right? It's very unclear, and it'll usually, again, guess something reasonable, but it's not necessarily what the user wants. And the tricky thing is that usually data engineers will know the answers, the people who built the schema, but not the people who are asking the questions. And in particular, the people who are asking the questions also don't even know SQL. So even if you showed them SQL, they wouldn't know what to do with it. So this is one huge problem you run into, is this notion of business terminology just does not match the underlying data. Now, the other issue is that even if the models do magically understand the schema, they're never going to be 100% accurate, right? Like SQL, the execution, like language itself, will have a lot of issues in the sense that you're just never going to have that 100% trust, right? And even after you go and you add almost every trick under the book, right? You can do RAG, you can do re-asking, all sorts of prompting tricks, which do help, right? To be clear, everything makes the numbers go up. You're never going to get to the point where users are going to 100% trust that the answer is going to be correct, right? And again, as I mentioned earlier, the users asking the questions don't know SQL. So even if you showed it to them and said, hey, look, what do you think? They'll say, I have no idea, right? Like they can't help you know if it's trustworthy or not. And so I'm going to talk a little bit about how, at least at Number Station, we address some of these issues. And then again, we'll up-level it at the end, because some of these tricky things around what's executed and how users speak are kind of these really fundamental problems when you're dealing with data agents. And so here again is kind of the classical text-to-SQL pipeline. I'll sort of morph it over time as we kind of talk about how we address the situation. Okay, so the first thing, and again, the first problem was this notion of business terminology and how users do not know the schema and don't know how to talk about the schema. And so what we lean on and build is this notion of a semantic layer. Now, a semantic layer is kind of, you search around, like it's a thing, it exists, it's a little fuzzy what it means. But our take on it is it's structured, but not as structured as you might think. It's almost a notion of how do you translate user terminology and user keywords onto the schema itself. And how we do it right now is very loosely through language, right? Through text. We're still dealing with language models. Language models need to understand text. And so we almost codify it this way. So for example, if you have the schema over here, one way is like, okay, look, again, we had that query about urgent work orders in July. So you could say, hey, look, I want to say that what an urgent work order means is the SQL question here, where its priority is in urgent and let's say very urgent, right? So and then there's a description that's describing what urgent work orders is. And so from here, in essence, you can think of this as like the name and description is in almost like semantic space. And the calculation is going to be in like data model SQL space. And so what the semantic layer is doing is building some translational mapping from, again, semantics down to execution. And similarly, you can have something for the date, where it's we're referencing when the work orders are created, and maybe here it's just referencing the created on column. But again, it's a mapping from semantics to SQL.
So one question though is now the user will come and might ask for pressing orders. And that's I'm going to map, right? So this is kind of like creating some templates.
Right.
It's okay, now how to translate from what the user wants to my schema, but then the user doesn't know to speak in the semantic layer terms, right?
Right, so it depends. Our assumption is at least, okay, so you get so there's a couple edge cases, ways you could take this. So we do assume for the most part that either a user is at least consistent themselves in how they talk about things. If a user changes up their own terminology, like that's going to be really hard to handle. But if a user comes in and asks for, high priority work orders, for one, we will, and I'll get to this in a minute, if you at least manifest this and describe what this is, they might at least be able to know if it's wrong or not, right? At least they can look at the description and be like, oh, that's not what I meant. Now to build up this semantic layer, how this is typically done is there is usually a notion of the creators of the semantic layer and the consumers of the semantic layer. And the creators are the ones who are gonna have who know the business knowledge and know the schema. And so usually there's an onboarding process where you go and you work with some of the creators, you look at the SQL logs, look at existing dashboards, and you kind of build a first version of this semantic layer and then build into it over time. So if a user comes and asks for priority work orders, if they, again, either will say and come back and be like, oh, hey, look, I don't know what that is. Can you either explain it to us, or at least we can flag it and like send it to maybe a data engineer to go and fix for us. So there's kind of this building over time. We're not going to get it 100% at the beginning.
So I have a follow-up question.
Yeah.
But then isn't this similar to kind of in the olden days, like we would have someone who would create forms, and then the user who doesn't know SQL would fill out a form that says urgent, yes, I care about something, right? And then that would generate the SQL in the back on behalf of the user, because it's kind of similar where you're going to say, except maybe it's a bit more composable. As opposed to saying this is one form that generates one SQL, I kind of have like form snippets that will generate SQL snippets.
Yeah.
And the LLM is really just putting those snippets together based on what the snippets that the user says. Put the SQL snippets together.
Yeah, so at a high level, they're very similar, and what we're really relying on is the fact these models are much better at fuzziness.
Mhm.
So when I said historically with kind of these forms, like it was almost like even like pre-embeddings, it would have been almost keyword matching, right? String matching. And so here you could handle a lot of noise in how the user talks, and typically you'll get users who say different versions of urgentness, like very urgent. They might even say high priority, and actually it usually means the same thing. And so the models are very good at handling a lot more fuzziness in this, which makes it a lot easier and more robust. Yeah. So we'll do both, like, usually we'll have some retrieval that happens because the semantic layer is very big. But then also the models themselves are very good at taking, again, like this notion of fuzziness from what a user means. Now, the other thing that can happen is if the enterprise is in a very common knowledge space, like we've had some people say like, oh, give me, work orders in the DC metro area. The models actually will have so much background knowledge that can actually sometimes understand what that means, DC metro area, on the schema itself. And we'll kind of, we can like add into the semantic layer over time. And so some things you're just relying on the fact that these models have been trained over a ton of generic knowledge to kind of build and understand these things, which also gives you a nice lift as well. And the dream eventually is you could even train models on business data and business kind of Wikipedias and so that it can actually incorporate a lot of inherent business knowledge, so it kind of know this automatically as well. We haven't played with that a ton, but that's the idea. So none of these ideas in my mind are that fantastically, I mean, again, none of this is new. It's more just kind of applying a lot of old standard data modeling techniques to the LLM era. And the thing here is like it ends up being just, if nothing else, also codifying all these descriptions with nice understanding. Some people just want that. Like they really like being able to see and have descriptions they can search over to kind of look at all of the kind of calculations in their organization. We found some number of bugs as well, where people actually think they're doing the same thing, but they're really not. And resolving those is also a whole other, the notion of verifying things is also kind of interesting as well, because you have different users with different amounts of knowledge and trustworthiness. And I will come back, this notion of a semantic layer is actually like a very interesting and kind of fundamentally hard problem of this translating from how users talk into the execution layer. Again, I'll come back to that kind of later on towards the end of the talk. Okay, so now going back to this kind of text-to-SQL pipeline, instead of it being question and schema directly to the language model, you now kind of have this question being fed through the semantic layer. And typically there's like retrieval done, so the model doesn't actually see the schema, it really just sees the semantics, which helps it understand your data more. And then, again, it would still go and spit out SQL. But again, you've done a ton of work on the data engineering side to build this kind of modeling layer, which is going to help the model understand how the users are talking. So the second question the second problem I mentioned was this idea that SQL itself is inherently, the models aren't really fully accurate. And in particular, when you're dealing with very complicated SQL, the models tend to break down, right? The more joins you have to deal with, the more tables, the more complicated forms, like they just have a really hard time outputting fully correct SQL. And in particular, so again, like you can assume here, we maybe have some database joins, and the user's asking some question that requires maybe an inner join on orders and providers, and again, looking at maybe high priority work orders in that space. And so our idea here is, instead of actually using SQL itself, what we really want to do is actually output to a little bit more of a language model friendly language that can get compiled down to SQL. And so what we actually do is we lean on the semantic layer here, and instead of having the model output SQL, we basically have it output semantics. And so what's going to happen is the model, instead of giving us SQL, is in essence, it's going to tell us what pieces of the semantic layer does the user want to build the SQL. And again, each of these, I might just hear it's assignee, but under the hood, this maps to a thing in semantics that has a SQL expression. And same with the aggregates, right? I'll say, oh, hey, look, I really want assignee and some notion of urgentness. And so we can actually go and map these to the SQL expression and go and compile this down to SQL. And so what you're doing here is you're basically giving the model the ability to interact with, to take as inputs, this like semantic space, and then to output as well into the semantic space. And the huge other win here, that in my mind is probably the most important thing, is that now a business user can actually understand what the model is doing. Because again, we're not outputting, I mean, we do compile SQL, but I can actually show this to a user in a UI, and they'll have some understanding of what we're getting at. And so going back, Magda, to your original issue, where you're like, oh, what do they say for priorities? Is maybe the model will pull up urgent. And at least in the UI, we can say like, hey, look, we're looking at urgency. This is the description. At least they'll have some understanding or some hope of seeing, oh, this isn't what I want. Like, I don't like this. Let me search for a different dimension. So it's really making SQL almost much more like business user friendly, and in a way that we can now start getting feedback from users, or at least some indication of like, this is wrong or this is right. Like anything that we can get to help understand our performance and quality is really valuable. And so this whole, like, how do you adapt the model to really be in the business semantic space is really important. And as a side note, this compilation, there's a few number of existing packages online that kind of will do a lot of this for you, as long as you do a good job building this layer. And there's some amount of all that work in automatic join mining is also comes back into play here, because you usually will kind of codify how to join between the tables beforehand. And so there's some work as well that you can do into like automatically discovering those. So then I know there's a lot of work in that space as well. And so that comes back. Okay, so now in this space, we're now, instead of it being text to SQL, we're now like text to semantic layer, which now again then gets fully executed on the SQL side of the world. And so this was basically the last like year of effort trying to build what did it take to build a good text to SQL agent that again could take a question and output SQL that could go run and get your result. Now, if you up-level this back again and we kind of abstract away to this problem of how do you make a good single agent, there are really sort of the two threads that I want to pull on here. Is the first one is again, as I said a lot recently is this idea of semantics, right? How users talk and talk about their information. Remember, I went back that whole chat slide of users talking back and forth to each other. They're talking in semantic space. So the more we can capture and work into that semantic space, like the more we're gonna have the ability to models to kind of communicate between between the different layers of the stack and kind of understand how the business users are talking. And just as much as important to build a semantic layer it is equally important for the model to kind of output into the semantic layer, because again, we're gonna have to get user feedback, and users only really understand this notion of semantics. And so the key thing here is that this semantic layer, this notion of business terminology and how it maps to the data model, how it maps to things that need to be executed, is sort of the core problem in my mind of how do you actually build good data agents, is you have to get them to understand, again, how users are speaking. Yeah.
Do you picture this semantic layer intermediate as something that like the user might ask the LLM, get like a first draft and then manually say like, no, actually I want it to be this or that? Or is the semantic layer always going to be output by the LLM and then executed directly after verification?
Yeah, so it's done, we do both for a little bit. So there's part of it that comes where the user is gonna come in and help us build it, where they say like, oh, this is wrong, let me fix it. They can edit descriptions, we make it editable especially by experts. We don't want anyone to do it. But then we do let the model itself add to the semantic layer if it thinks it's missing a piece of information.
I guess I mean for a particular query, when it outputs into the semantic layer, like do you picture the business user modeling the output of the query that's been translated to semantic layer?
Wait, can you repeat it? So yeah, we definitely show the semantic output to users.
Yeah, like then do you picture the user, I guess, like editing that? Or
they can, yeah, absolutely.
Proper language, I guess, is what I'm trying to get at, that they could like edit meaningfully.
Yeah, so it's not free form, like a lot of it is almost via search. So you can almost think of it as, technically speaking, we have a deterministic finite set of like things that they could pull from for like aggregates and group by columns. And so in essence, if they want to change it, they can almost say like, oh, hey, look, I'm looking for this. And we can almost manifest it as a search problem.
Okay.
So it's much more, it's not like a free form language where they have to enter it and magically know. It's very much like glorified autocomplete, basically.
Yeah.
Yeah. But yeah, so that ends up being really important. And there's like actually a whole can of worms where if users edit the semantic layer, you now have to actually propagate those changes back into like the question and the description and eventually also into the plan itself, right? So when the user gives you feedback, it now means like something else that you did was a little bit wrong. And so there's actually this whole like update process that you go through when they actually make edits, which is also pretty interesting. Okay, so we've now sort of talked again about this notion of a single agent, and now I'm going to spend the last sort of 8-ish minutes, hopefully, talking a lot about this notion of planning and coordination. And this is still very much work in progress, and a lot of it is kind of the hypotheses that we've been building over the last couple of weeks and months about what is it actually going to take to build this sort of dream of this kind of multi-agent workflow. And so to start, I'm going to give a fairly concrete example of what an actual end-to-end workflow would look like, built kind of on top of that text-to-SQL use case that we saw before. And so here we have a user who's coming in and saying, hey, look, how can I maybe reduce my cost in the US? Maybe you have these work orders that all have a cost associated with them. And so as I mentioned earlier, you almost always have this notion of a planner agent that's going to start and at least try to break down the task given the set of agents that you have. And so if you here, let's assume you have, again, what I'm assuming are kind of classic, or what will hopefully soon be classic and common data agents. So the first thing that's going to happen, let's pretend in this case, is it's going to go and call out to this text-to-SQL agent to start to understand how the data can start to answer reducing the cost. And maybe the planner understands that, hey, look, what you first need to do is look at the number of orders, the suppliers, and the cost in every state. This gets sent off to the text-to-SQL agent. It then goes, and as we just talked about, we'll go and do also semantic layer stuff and then go and execute SQL, and we'll give you some output table that's looking at this. Ideally, there's probably gonna have to be some analyzer agent that understands what the table is saying and understands like, hey, look, this number is this cost is a lot higher than this other cost. So maybe I want to do something with the suppliers. Again, this is very hand wavy and pipe dream in a moment, but I'll get to potentially how you can make it happen. And then it's going to call out, maybe let's say to an action agent that's like, oh, maybe you want to swap supplier 1 for supplier 3 to reduce the cost, right? I mean, again, to be clear, this is the pipe dream. Like this does not actually exist in the world today. But this is, again, what we want to aim towards is this idea of walking through the analytics pipeline and having these models understand what the user wants, like how to refine the data, how to get the data, and how to take action on the data are kind of these core paradigms here that we're building off of. And as I said before, this doesn't exist because there's, I think, in my mind, at least at the moment, 3 really hard problems that need to be solved first. Now, the first one is that at every enterprise, you get fairly kind of idiosyncratic, unique workflows, right? Every enterprise is going to have a different set of actions that they take. And in particular, they'll have different sets of rules that they follow, right? For one company, maybe they can never change the suppliers, but perhaps they can change how much they're offering. Like maybe there's a lot of leeway in how much they're buying. For another company, maybe they can completely change the suppliers and they can't change other pieces, right? So there's a lot of just very business specific things that need to happen. Now, this is actually a huge thing that I think makes data workflows a lot harder than the code agents that we saw earlier, right? Like code by and large, I could ask any one of you how to decompose a coding problem, and like for the most part, like you'll probably actually do a decent job. Like there's probably some fairly sort of specific, things about like compilers that you may not know and may not know how to solve. But by and large, like coding itself, it's why there's coding classes, right? Like you can actually, there's a massive shared wealth of knowledge. And there's only like 3 or 4 real agents that you need, which makes that problem, I think, much more tangible than some of the data analytics workflow pieces. The other huge piece, which is going to be a massive thing to try to figure out, is how do you actually get this notion of an automatic analyzer agent, right? In essence, this is how do you automate business analytics, which is a very hard problem. And even if you break it down some, it's really hard to understand what kind of analysis users are doing to solve their problem, right? Again, this is, as I mentioned, the first problem, it's going to be pretty specific to the enterprise itself. So how can you actually even start to automate this process and take analytical actions for a user to understand how to help them understand their data? And the last thing is that, I feel like even more so than just code, analytics is a very iterative process. And not only is getting a question sort of iterative, but as you understand the questions more, your set of questions will change, right? So for code, I can almost break down the plan. And although each plan itself, each like subtask is iterative, like the plan itself is probably largely unchanged. For this kind of workflow, right, like the plan has got to be very dynamic and flexible, because an answer to a question may actually lead you to want to ask and change the questions and change the actions, right? It's a much more sort of loose space that you're in, and it'll be a little harder to manage. Okay, so all of these right now are sort of our current hypotheses of how to solve this, and are still, again, as I mentioned earlier, very much work in progress. So for this notion of how do you solve this kind of idiosyncratic workflow, I think what you're going to need is really pulling on the same idea of a semantic layer, but build almost a notion of an action semantic layer, right? At the end of the day, actions are, right now I have them as API calls, but if you really squint from like 20,000 feet, they're almost schemas in a database, right? Like each action is basically a function call. And if you kind of squint, function calls are almost like relations with attributes, right? With columns. Most faces like sure is. Again, so in essence, there's a lot you can do mining actions from even observing users, from looking at this is on fast APIs, like an API documentation. Where in essence, you're back into the semantic layer where you have a notion of like what action you're doing, like describing it, and then again, understanding like how you actually execute that action. And so I think there's going to be a way that you can almost onboard and build semantic layers for enterprise actions. So the model, again, given what the user says, which is like, oh, assign these work orders, can understand what action to actually take without, again, the code itself is abstracted away. The model just needs to understand what the user wants and how it relates to kind of the text, the semantics of the sort of action semantic layer. There's gonna be a lot of work on how do you build this, and there's been some really recent work that I think it was submitted to DLDB, which was like watching videos and kind of trying to record and codify some of these like notions of like what actions people were taking. So there's going to be hopefully some fun work coming out soon, which is understanding how you can potentially start to build these semantic layers. Okay, so that's sort of potentially one way you can handle kind of a lot of the idiosyncratic workflows is, again, you capture the semantics and how they actually get executed by each enterprise. So this last, I think in my head, again, the one I'm most interested in has been, as I said, is keeping me up the most at night right now, is how do you actually build an analytics agent? And I don't 100% know the answer, but I know that the first step is going to be at least to try to record the analytics that the user is doing. Because right now, if the analytics is done outside of the system, you have no idea what they're doing and have no hope of automating or understanding any of it. And so one thing that we've been thinking a lot about recently is that there's a lot of databases that in the last couple of years have added a lot of analytical functions to their SQL language, right? Like Teradata has a whole slew of analytical functions. Snowflake has it's Snowpark, which is Python, but it's basically a bunch of Python UDFs that run on the table. I think BigQuery has a whole bunch of analytical functions. And so the idea is, okay, let's first build into your SQL language, move beyond the kind of standards like project join and move into some of these analytical functions. So at least you can start to understand and capture and record the kinds of questions lead to what kind of analytical results. And at first you can even do this by like getting a lot of feedback from the user, right? So if you have a question that you don't really know how to answer, you could ask them, be like, hey, look, like, I think you mean one of these 5 semantics or one of these 5 sort of analytical functions, like which one do you want? They can tell you and you can go and run it, right? So it's more manual at first, but at least you can start to record it and build these into your pipeline. And the dream is that, hey, look, if you get enough of these examples and understanding, you can start to kind of collect and eventually train a model to eventually do this for them. So ideally you can remove that middle step and eventually go directly from question to analytics. And now this isn't, and so once you get this analytics, there's gonna be some other whole pipeline, which again, I think will be built similarly, which is understanding the outputs of these analytics and how they actually relate to the problem at hand. And so again, this is all still very much work in progress, but I think there's gonna be something here where, you first record the actions and then start to automate it. Now, the last piece, which hopefully ties all this together, is I think for this, when you build these workflows, there's gonna have to be, even more so than you saw in that kind of code example, users in the loop at almost every single step. Right, and I don't mean users like telling them what to do, but if nothing else, just looking at the output and even just giving thumbs up, thumbs down, right? Some notion of, are we on the right track or not? And what this is, so, for example, what this would let them do is bake in and allow a lot more flexibility into the plan, because we are actually, like, we know that they're the source of truth. And so if they help us, for example, modify the plan, then we know we can take action according to that. For example, if we see the model says, hey, look, like, this is the correlation, I think you should do this, they can kind of again say, oh yeah, this is great, or like, oh no, like keep trying, or give us some positive or negative feedback. Again, this will be, for the most part, kind of an onboarding step. But the idea is, as long as you kind of get the feedback that you need, you're going to be able to support, hopefully start to support more complex plans and learn over time what users are okay with or not. And it also helps a lot with trust, building trust in the system, which users inherently are a little untrustworthy of some of these like kind of fancier AI ML features. And so if you build in a lot of sort of verification steps and checks so they can see what you're doing and understand it, they're kind of, hopefully be more positive and help you build it over time. Yeah.
Try to use other models to do the verification.
To do the you mean like verifying the outputs? Yeah, so I didn't talk about this, but a lot of what you do when you have these agents is you almost always have, it's almost called like, some people call it self-reflection or like re-asking, where there'll almost be like micro chats between an agent and like a verifier, who can go and come and like, ideally you can at some point be able to automate it, but a lot of it is like to type check and make sure it's doing the best thing. And so you end up using a mixture of other models, code backends, like you can actually run SQL and be like, oh, here's an error, like fix it. And sometimes it does it, or even a user. So in essence, it's like when you call it to an agent, there's that workflow, that like kind of verification flow will happen. Between, so almost you can think of it as like the SQL agent will then have a micro chat with the verifier. And that's a huge thing that also gets it to a quality lift. Now for people who've actually built UIs before, or cared a lot about that, the huge other bottleneck I haven't even talked about is that the more calls to a language model, the slower it is. And users, it's hard to express the importance of immediate feedback, right? The minute things get too slow, they will not iterate. Like they just won't do it again because they're like, oh, it took more than And like the time is like a lot faster than you'd want. Like after 5 to 10 seconds, I mean, they'll wait for an answer, but they will not feedback. Like they won't give feedback, they won't engage because it's just too slow. Like they don't want to wait again. So very frequently, like if there's something, if the first answer is bad and it's more than 10 seconds, they'll usually just like submit a ticket and, and they're like, I don't like this answer. And you're like, well, just like try, like just change one word, or like your spelling is wrong, like it's little things like that. And so I just remember like I think Jeff Hare had his talk that was like, there was some study done some number of years ago that was like, you need within half a second for interactive visualizations. And I'm not even hoping for that, man. Like I'm hoping for 5 seconds would make me happy. And so the issue with all this re-asking is it makes things a lot slower. And so there's this huge problem of like, not necessarily a problem, but it's a challenge of what do you show to the user to keep them engaged in a way that can still let the models do what they're good at. And so you don't necessarily have to stream everything, but like you need to be thinking about continual feedback, continual progress updates, continual points of interaction, right? Like you just want to keep them engaged in the problem so they're willing to kind of continually get feedback and improve it. Which is another like and also building backends that stream everything it's been a fun challenge for those who don't have any experience in it before, which I didn't. So yeah, that's been fun. And then you also play games where you can like mix and match which models do the verification. So like ideally you'd have the faster models do a lot of the small calls and then like bigger models do the planning. Sometimes you also just want the fastest model to do everything. But anyway, you can like play a ton of games there as well to kind of get good performance, which is pretty fun. Okay, I think I'm oh perfect. So yeah, actually I'm like right at towards the end here. So yeah, I mean I guess the high level here is I'm fairly convinced these like language model, these kind of agents are coming in general, right? You'll see them, I mean, for databases, for data workflows, ideally, and we're already seeing them take over a lot of the coding spaces and stuff. And it's one of those things where with all of this, the highlight here is that most of the fixes that I've talked about are all data fixes. Most of them are not model fixes, right? Like the ML stuff, it's a hard and it's a problem, but by and large, the hardest thing that we do every day at the company is deal with some of the data issues. Like how do you model it? How do you build it? How do you build the semantic layer? And also a lot of UX problems as well. Like how do you engage the user correctly? And so again, but all the work that we're doing on building single agents still can be still can be very valid. It's just we're moving into this space where a lot of automation is coming and workflows and like how do you actually think about automating these things, I think is really interesting. And hopefully we'll see kind of the world taken by storm pretty soon where things that the dream of things that are being automated will actually maybe one day happen. So we'll see. Yeah, that's pretty much all I have. And again, thank you. And do not hesitate to ever reach out if you have questions.
Okay, thank you, Laurel. Okay,
You can stop it.
we stop recording and then we have time for questions. So actually, I had a question and I didn't want to interrupt. So this semantic layer, very interesting. But you didn't describe the details.